Hello, my wondrous Algebra 3 students. We are ready for another exciting online trip. Remember that there are four conics: the circle, the parabola, the ellipse, and the hyperbola. Today, we will graph the hyperbola with its center at the origin. Each hyperbola will have two parts or two branches. Two parts or two branches. Some books use branches. That's why I'm putting that there. Remember how we slice two cones to get our hyperbola? You see, there's a part here and here's a part here, our hyperbola. A hyperbola is a set of points in a plane, the difference of whose distances from two fixed points are called the foci points. Remember, we had foci points with the ellipse. We're going to also have foci points with the hyperbola. See how they're like on the interior of the branches? But we're going to have, we have two foci points, like we had two foci points for the ellipse. Here's the center. Our transverse axis is horizontal here. You see the branches are opening left and right. So this is called the transverse axis, and the center is on the transverse axis. We were talking about the hyperbola is a set of points in a plane, the difference of whose distances from two fixed points is called the foci point. See, here's a point on the hyperbola. Here's a distance d sub 2. Here's a distance d sub 1. When you subtract those, the absolute value will always be equal to 2a. Talking again about the different parts here. The line through the foci intersects the hyperbola at 2 points. You see, right here, right here. These 2 points are called the vertices. You see, the vertex and the vertex. The line segment that joins the vertices is the transverse axis. You see, since it's opening left and right, it's going to be, and the vertices are on this. This is our transverse axis. The midpoint is the center. The center is always, we're going to always move from the midpoint like we were doing for the ellipse. Let's look at more detail at the key features of the hyperbola. So here's the center. Here is the transverse axis, because you see the branches are opening right and left, and the transverse axis is horizontal. Here is the focus point. Vertex again, vertex. This part of the rectangle up here is called a co-vertex. And we're going to have we're going to have slant asymptotes to help us sketch our hyperbola, so we'll know exactly how wide or how close together the branches are. Here we have a horizontal hyperbola. You see branches opening left and right. Here we have a vertical hyperbola. The branches are opening up and down. So this is vertical, this is horizontal. Let's look at the equation of the hyperbola. We're going to look at the equation of the hyperbola when the center is at the origin. Notice it looks just like the equation for the ellipse, except we have a minus sign. So again, the hyperbola, it looks just like the equations for the ellipse, but we're going to have the minus sign. So you have the minus sign here. And notice also that the a square is under the positive term. You see, there's understood to be a positive sign here in front of the x square, a positive sign in front of the y square term. So the a square is always under the positive term. And this time, the a square does not have to be greater than the b square, as long as the a square is under the positive term. Again, the a square does not have to be greater than the b square. The a square is always under the positive term. So if the a square is under the positive x term, you see it's opening left and right. If the a squared term is under the y variable, you see it's opening what? Up and down. So what we're going to do now, we're going to sketch this hyperbola. And the first thing I'll ask is the transverse axis vertical or horizontal? It's going to be vertical because you'll notice here that the a square, which is always under the positive term, is under the y square. So the a square, which is always under the positive term this time, is the a square. And again, notice this time for the hyperbola, the a square does not have to be bigger than the b square. The second thing we're going to do, we're going to find the a. And this a that I did not put here correctly. So this a will be a 3. This a will be a 3. And the b will be a 4. Same thing what we're doing for the ellipse. Then we're going to find the center. We're going to find the center. See, the center is at the what? It's at the origin. Because there's nothing being subtracted from the x or the y. So 5, we're going to sketch the hyperbola. We're going to sketch the rectangle first so that we can sketch the asymptote. So this is how we're going to do it. We're going to use the a and the b. So let's look at this. See, we draw an xy axis. Remember that the a is 3. And since it's under the y term from the center, see, we always move from the center. We'll go up 3 units and down 3 units. Remember, the b was equal to 4. So from the center, we move to the right 4 and we move to the left 4 units. So you see the 4 points here. Let me emphasize those again. See the four points on the outside of the center right there. We're going to use those 4 points to sketch our rectangle. Going to use those 4 points. You see how I dashed it. See, I dashed it, had it formed a little rectangle going through there. It doesn't go any further than -4 to +4, and then it goes up from what, +3 to what, -3. So I sketched the rectangle. Once I sketch the rectangle, I can sketch the asymptotes. See, these are asymptotes. The branches of the hyperbola will be getting closer and closer and closer to these asymptotes, but they will never touch, never cross. So, and I go from corner to corner of the rectangle. You see, corner to corner of the rectangle to sketch the what? The asymptotes. And finally, I'm going to draw my 2 branches. Remember, the a square is under the y square. See, the y square is a positive term, so the branches will be opening what? Up and down. And you see how I start here at the vertex. See that vertex right there? And then I'm going to have the branches getting closer and closer and closer to the slant asymptotes here, these diagonals, but never touching, never crossing. So that is one example of how we sketch this hyperbola step by step. And remember to stop, rewind, review. This video, stop, rewind, review. My love going out to you.